I'd like to welcome you to the International Design Project. My name's Chris Tidy and I'll be supervising the project this semester. I'd like to begin by telling you a bit about the background to the project and the goals. You'll get the chance in this project to design and build a prototype from the very beginning, from the first ideas through to the concept selection, picking the best idea, then optimizing the concept, doing the detailed design, and then hopefully building it in the workshop and testing it to see if it works as you intended. And the goals of this project are that we wanted to give the students the chance to go through all these stages in a single project, because that's something that's quite unusual. You wouldn't normally get the chance in a company to design a project from the very beginning and then at the very end also build the prototype and test it. Normally you'd be focused on something much smaller, much more specialized. And we also want to give you the chance to learn some practical skills, so things like basic metalworking skills, cutting metal, drilling, riveting, soldering, that kind of thing. You may get the chance to improve your skills in programming, in simulation, in work with things like Arduino microprocessors. And we want to give you the chance to work together in a team to learn from the experience. You may find that at times that's difficult. Maybe sometimes you have arguments, maybe you have disagreements that you have to spend a lot of time resolving. Maybe you make mistakes in the design, maybe things don't work the way you intended, and you'll have to figure out solutions to these things. And we also hope that you learn that at the end of the project, then sometimes despite these differences, a good result comes out at the end. And it's also the intention that you'll get the chance to improve your technical English skills. So this whole project takes place in English, and you'll, in the course of the project, be preparing a chapter for a project book, like this one. This is the one from the year 2017. You can see in here there are 4 projects that are described, 4 different projects which the students built, and they've detailed here how they went through the design process and what the end result was like. They've done it very much in their own way and in their own style. And this semester things are going to be a little bit different, obviously. The course has been divided into 2 halves. So the first half will take place entirely online, and this will be the phase through from the idea generation and getting to know your teammates at the beginning of the project, through to the final design, when you know exactly what materials you need and you have some final drawings for your project. Then hopefully in the second part of the project, we'll have the chance to build the prototypes here in Hanover in the first 2 weeks of September. So it's important that you keep these 2 weeks free and make sure you're in Hanover at that time. We'll also be joined by a few participants from Purdue University in the USA, and I'd like to take this opportunity to extend a warm welcome to them. Now, the assignment this year is to develop a prototype which can be built and tested and used in a developing country. And you'll only have a very limited budget for this project. You'll only be able to spend 125 euros on materials that you need for the project. And it's essential that in this project you make use of some reused materials. So things that people could easily find by, say, taking apart broken products, by, say, visiting demolition sites, things that they might already have, and things that can be achieved, things that can be worked and manufactured using basic tools and basic skills. And you'll often find when you do some research into these countries and the markets that there are some things that can be done much more easily there and much more commonly than in Europe, and there are other things that are nearly impossible. If you look at something like, say, a tractor, it's a big disadvantage to have a tractor that has a lot of electronics in a developing country, because these are then reliant on things like software, laptops, connector cables, expertise from the manufacturer for diagnosing problems and servicing. And the same goes even for something simpler like, say, a coffee machine. As soon as you put a microprocessor inside it, it becomes a lot more difficult to repair or to service without the skills. When it comes to the types of shapes that you would use, the types of components that you might use in your prototype, it's also important to think about how easy it is to make these. Generally, flat shapes are easier to make than curved shapes. And a lot of materials are relatively easy to find in flat shapes or straight shapes and harder to find in curved shapes. Now, what we've had in previous semesters, to give you a few examples, in the last semester, the winter semester, my students built a device that could take a polyester bottle, so a disposable drinking bottle, and it could take the bottle and then using a razor blade, it would spin the bottle and the razor blade would cut a spiral out of the bottle. It would do this through 3 bottles and then wind the spirals together to make a rope. Now, the previous semester I had some students who built a prototype out of an old hot plate, and they had a piston and a cylinder mounted on the hot plate, and you could fill the cylinder with broken ABS plastic from computers and power tools and things like that. You could turn on the hot plate, get it to the right temperature, and you could wind a handle which would then push the ABS plastic down against the hot plate, and through a nozzle at the bottom it would extrude a filament which could then be used in a 3D printer. I also had a group of students who built a refrigerator that would keep food cool without needing any electricity, and it worked by using a steel container, a steel pot, which was surrounded by a lot of absorbent material, so cloths and towels and things like that, and then it soaked up water from the base the whole time, and the water then evaporated and cooled the food inside the machine. Now, I'll be uploading some pictures of these previous concepts in the next week, so you'll get a chance to take a look at what students have done in previous semesters. I'll also upload a couple of copies of the project book from previous years, and I'd like to show you a few examples at this stage of products that are made using reclaimed materials. The first one I'll show you is here, and this is a very simple device that was made in South Africa, and you can see it's got a piece of board at the back here, and there are then 2 square battens that are screwed onto the side, and in each of these wooden battens there's a piece of an old saw blade mounted. Now the idea is, because these slope together, you can take something and you can wedge it between the saw blades. The idea is you can undo the cap of a jar which has become stuck. It's quite a common problem if you have a jam jar or a honey pot like this, that after a while the honey dries out inside and you can no longer get it off. And if you put it between these saw blades here, the teeth grip the cap and you can rotate it and open the honey pot. Now, you can see it's quite difficult to make these teeth in a piece of steel, and this design uses the teeth that have already been made in a factory in a saw blade. And these teeth are the right shape, they're also hardened, and it doesn't matter very much if they're slightly blunt, they still work. It also does next to no damage to the cap, so you can put the cap back on and use your honey pot again. Another thing I'll show you is a device that's been made out of reclaimed materials in Germany. You can see it here. It's a bell which is made from the neck of an oxygen cylinder from a welding shop. Now, this is very heavy steel. It would be very difficult to make this in this shape. You'd need a very big machine in a factory to be able to deform the steel into this dome shape. But it's the perfect shape for making a bell, and what they've done is slice off the neck and then inside add a clapper so that when you hold it up and ring the clapper against the side, it resonates. The third thing I'll show you here is the lamp here, which is built almost entirely from a waste material from our own university, Leibniz University. Here at the top, there's a halogen lamp from an optical lab, and below it there's a flexible neck. Then there's a catalyst tube from a chemistry laboratory with porous pot beads inside it to act as the catalyst. Below that, there's the neck of an aluminium fire extinguisher, a carbon dioxide fire extinguisher, which has been cut off. And at the bottom, to give it some weight, there's a toothed belt pulley. And right down at the bottom, there's a V-belt which is curled up into a spiral to make a rubber foot. These are hopefully things that will give you ideas for what you might be able to build in the project, for what you might be able to reuse. I will remind you of two things. It must be something that's affordable. It must be something that's practical to make with the available materials and with the available skills. You'll need to do some research to figure out what kind of skills and materials are available in the country of your choice. And it needs to be something useful. So I know it would probably be fun to make a dartboard out of used materials, that kind of thing. I'd prefer it if you didn't. I'd prefer it if it was something that was a little more useful and a little more related to engineering than a dartboard. And I'd like it to be something which suits the skills within your team. You may find that you're all mechanical engineers in your team, in which case, great, build something that's primarily mechanical. But if you've got a split, 50% electrical engineers, 50% mechanical engineers, or maybe you've got an information engineer or a mechatronics student, something like that in your team, then think up a concept that suits all of you, because that's very important from the point of view of the course being effective for your learning. Some books that I recommend here, apart from the project books from previous years, which I'll upload, the first book I'd recommend is The Design of Everyday Things by Donald Norman. This is quite a short book. It's quite readable. It's got a lot about usability, about ergonomics, about the design process in it, and it's full of fascinating examples. There are lots of examples of things that are well designed and badly designed, lots of pictures. You should be able to get this from the university library. You may be able to get an electronic version from the university library. If not, you may be able to find an electronic version online, or the paperback book itself is not particularly expensive. The second book I recommend is a classic in the world of design, over 60 years old now, Designing for People by Henry Dreyfuss, who is a famous American product designer. This is a very readable book, a very enjoyable book, and one that I definitely suggest you read. Maybe it's something that's at a slightly higher level in language terms than Donald Norman's book, so especially one for the people who are more advanced in English and want to improve their technical English. For those of you who are maybe interested in something more entertaining, Raymond Louis' book, Never Leave Well Enough Alone, is basically a story about his life as a designer. There are lots of interesting examples in there, lots of technical vocabulary, lots of things that he hated, machines and people, and a very entertaining account of his life, one that I'd strongly recommend. At the end of this week, I'll be uploading an information sheet and an exercise sheet about idea generation, so how you come up with your first ideas. And it's important that you come up with more than one idea. People sometimes come up with a single idea and they get very, very committed to this idea, maybe obsessed with this idea, and they are convinced that it is a good idea even if everyone else thinks it's a bad idea. Be careful for that one. As Richard Feynman said, you are the easiest person to fool. And the assessment of the course will in part be based on the quality of the prototype that you design at the end of the course, and in part be based on your thinking and the short assignments that you complete during the course. At this stage, I'd like to advise you to start thinking, start doing some research into developing countries that might interest you. Some of you maybe come from developing countries or have lived in a developing country, and look everywhere around you. Look at all the machines which then in the future might become waste and might serve as your reclaimed materials for your project. Be curious, look at everything in a new light, and never stop thinking. Thank you.